Good morning, afternoon, or evening to everyone joining us today. My name is Jessica Taylor, and I'm here at the Canadian Centre for Evidence-Based Conservation in Ottawa, Canada, and we're located on the traditional unceded territory of the Algonquin Anishinaabe people. On behalf of the Collaboration for Environmental Evidence, I'd like to welcome you all to our March session of the Environmental Evidence Summit webinar series. We have a very interesting session ahead of us, one that is set to be one of our most well-attended of the series so far. So comparing rapid and systematic review methods for environmental evidence, benefits and limitations of different approaches will be chaired by Kate Schofield and Angus Webb. So to get things started, I will hand it over to you, Kate.
Great, thanks, Jess. And thank you everyone for attending and for all of the presenters who are representing, I think, the breadth of time zones we can potentially get. The first presenter in our session will be Jeff Frampton. Jeff is a senior research fellow at Southampton Health Technology Assessment Center. He has experience in designing and running environmental research studies, conducting evidence syntheses on a wide range of topics, and developing guidelines on evidence synthesis methods. Jeff's talk will be on critical appraisal and systematic reviews and rapid reviews. And Jeff, you're all set. I can see your slide.
Great, thank you very much. I'm going to take on the fairly daunting task of talking about critical appraisal in systematic reviews and rapid reviews in about 15 minutes. I think the topic really deserves an encyclopedia or two. I suppose the first question we need to ask ourselves is what actually is a rapid review? And the consensus of opinion seems to be that there actually is no consensus on the definition. There have been a few attempts to kind of reconcile this, and recently Hamel and colleagues did a thematic analysis based on a scoping review to try and bring together the concepts and capture the main sort of ideas about what a rapid review is. And they've encapsulated this in a sort of definition they came up with, which is that a rapid review is a form of knowledge synthesis that accelerates the process of conducting a traditional systematic review through streamlining or omitting a variety of methods to produce evidence in a resource-efficient manner. They refer to a systematic review, and I think the consensus here seems to be that the benchmark of a rapid review is a systematic review. So although there isn't much consensus, I think most of us probably would agree that systematic review is the reference point for rapid reviews. And I'm going to use that as the sort of focus for this particular presentation when talking about critical appraisal. I'm going to assume that the way we do critical appraisal in systematic reviews is appropriate for the way we would want to do critical appraisal in rapid reviews. And there might be other paradigms out there for rapid reviews, but that's not within the scope of my presentation now. So given that the benchmark of rapid reviews are systematic reviews, I suppose a good starting point is to have a think about how we go about doing critical appraisal in systematic reviews. So I'll firstly talk about that. And to get a sample of systematic reviews to consider, I randomly sampled the CEDAR database. So CEDAR is an evidence service provided by the Collaboration for Environmental Evidence. It's an open access database of evidence reviews in environmental policy and practice, which have been published each year since 2018 when the service was set up. And it includes any reviews which address a question or topic with relevance to environmental policy or practice, and which aim to synthesize primary studies to provide a measure or estimate of effect. So this is a database of a good cross-section of published effectiveness reviews, not limited to systematic reviews, although I've taken a random sample from the database to get a cross-section of systematic reviews. And I used the keyword systematic review, exactly like that, to search for papers which were described as systematic reviews in the title or abstract. I didn't use any other terms like systematic literature review because there are debates about, where the boundaries of systematic review lie. So I've got a cross section of these very recent. So this search I did was on a month ago roughly. So it's fairly recent cross section of these systematic reviews, and there are 50 of them randomly selected. And so this table just shows a breakdown of these 50 environmental policy and practice systematic reviews. Here they are shown by publication year. And what I've done here is I've just put in this table a couple of key points. The first is just illustrating that the proportion which didn't have any critical appraisal stage, and then just as a related thing, the proportion that didn't have any Prisma or Rosie's checklist. And I was originally looking to find lots of systematic reviews that have done critical appraisal to find lots of examples of how critical appraisal has been done. But what we actually find is that the vast majority haven't done any critical appraisal, sort of 60 to 71%, with no real improvement over this small timescale that I sampled. The good news is that of these 50 systematic reviews, 7 of them were CEE systematic reviews as published in Environmental Evidence Journal. And the remainder, the other 43, were published in all sorts of other journals, but not CEE ones. None of the CEE systematic reviews didn't have critical appraisal, so that's all right. But overall, 77% of systematic reviews in environmental policy and practice don't have a critical appraisal stage, and most of them don't have Prisma or ROSE's checklists. And I suppose, you know, we could ask ourselves, does it matter? You know, I think because these are effectiveness reviews, the answer is probably yes. You probably ought to be interested in you know, the validity of the evidence if we're talking about effectiveness. Now, the problem with most of these reviews not actually doing critical appraisal is it kind of gives us a fairly small sample size of those that actually did, which is only 17. But we can look at those and see whether they did critical appraisal in a way which was fit for purpose or not. And what I've done here quickly, I've summarized in a table here 6 kind of pointers to look at, you know, whether systematic review critical appraisal is fit for purpose. These first 2 are positive aspects, which, you know, a high percentage means that that's a good thing. These remaining 4 are negative aspects, and a high percentage is a bad thing. But just to sort of summarize quickly, with effectiveness reviews, you'd hope that there'd be some focus on internal validity, but not all of the reviews did that. 71% of CE systematic reviews did, but still 29% didn't. But then of those systematic reviews that did focus on internal validity, most of them did not include all the key internal validity domains, so some risks of bias were missing. Another common problem in systematic reviews is that they conflated quality constructs. So that means that they focused on, they mixed together all sorts of different aspects of quality, not just internal validity, and I'll talk a bit more about that in a moment. They also used numeric scores in a number of cases, fortunately not the CEE systematic reviews. In this particular case, but numeric scores have quite a few issues because they give a false impression that the constructs that you're actually summarizing in the score are additive or multiplicative, and they're not transparent. And not all of the systematic reviews fully inform the data synthesis. So, for example, sometimes they did inform data synthesis only for some studies or some outcomes, or in other cases, studies were arbitrarily excluded. And then most of the systematic reviews had some kind of issue with transparency. Judgments and decisions weren't explained clearly. So quite a few issues around the systematic reviews that are in this random sample. So just going back to this issue about conflating quality constructs, a lot of systematic reviews refer to quality, which isn't that helpful because quality is not consistently defined by anybody. What could quality mean? Quality can mean all sorts of things. It could mean the appropriateness of the question, external validity, whether the literature was peer reviewed. It could refer to random error. It could refer to internal validity. It could refer to all sorts of things. What we think is important is to focus in effectiveness reviews on internal validity, because the key point is we're interested in systematic error. We're interested to know whether our results might end up being biased and unbelievable. So the first problem is the conflation of internal validity with all sorts of other things that could be called quality. The second problem is that even when systematic reviews did focus on internal validity, they then missed out some of these key domains of internal validity. So quite a few little issues there, you know, to think about. So what we've been thinking about is trying to improve the guidance that's available to try and see if we can improve the standard of systematic reviews. Now, review teams face a number of challenges when doing environmental management systematic reviews. Obviously, they face a range of study designs with different validity issues. There's a wide range of critical appraisal tools available. Most of these have been developed in health research. It's not always very clear which of these are fit for purpose. And there may be some kinds of study design where it's not obvious that any tools particularly fit very well. So many review teams end up developing their own ad hoc critical appraisal criteria. Now, the CEE's guidance on critical appraisal is pretty limited. There is some guidance, but it doesn't really address many of the issues I've just flagged up. So, and these challenges might really explain why there's such a poor uptake of critical appraisal in systematic reviews, although the CEE reviews are better than the others. So what we've been trying to do is to improve the guidance on critical appraisal, and this is a work in progress. We've nearly got there after many years of slaving away on the manuscript. We're basically following a plan, conduct, report, apply framework, which just makes logical sense. But we've also come up with the idea that 4 core principles of critical appraisal could be very helpful. We found these very useful principles, and I'd just like to explain those now. So these principles state that critical appraisal should be focused, extensive, applied, and transparent. And there's a useful mnemonic there, FEAT, to help you remember what that is. Now, these are core principles of critical appraisal that apply already to all fit-for-purpose existing tools, such as the Cochrane risk of bias tools. And they are completely independent of the type of evidence synthesis and topic, because they're overarching core principles. So just to briefly explain these, so critical appraisal should be focused on a relevant construct. So logically, for quantitative reviews, this construct really ought to be systematic error. So we'd be looking at internal validity. You could have other constructs, but you've got to have a clear focus, and it's got to be really obvious what that focus is to go about a critical appraisal. Furthermore, the critical appraisal should be extensive, and that means that all relevant domains of the construct should be captured. So if the construct is internal validity, then we've got to capture all of the types of internal validity, you know, selection bias, attrition bias, various other types of confounding. We don't just miss half of them out and call it internal validity. Critical appraisal should also be applied. And that means that the output of the critical appraisal exercise should inform the data synthesis in an appropriate way, not conflating the assessment constructs that I just mentioned in that diagram. So we're clear about what is going in to inform the data synthesis. Is it internal validity or is it something else? Okay. And there should be clear decisions, clear judgments reported for all decisions made. And then finally, like all aspects of a systematic review, critical appraisal should be transparent. So the definition of the assessment construct and the rationale for the judgments made for each study and outcome should be reported. So I'm just going to illustrate whether or not the systematic reviews from that random sample that I took match up to these core principles, FEAT. And the bad news is not very well. So these are the core principles here: focus on internal validity, extensiveness, in other words, capturing all the relevant domains of bias, application to make sure we actually inform the data synthesis, and then transparent reporting of judgments and definitions. And these are fairly low percentages, fairly small numbers, because only 17 of those reviews did critical appraisal. So this is not a massive sample, but you get the gist that things aren't great. CE reviews fared better in some areas and not so well in others. So there is some room for improvement here, I think. So that's the situation with, that's a very quick overview of the situation with systematic reviews. What about rapid reviews? Well, there have been various attempts to try and look at the structure of rapid reviews, the different stages, and compare rapid reviews against systematic reviews. But they've almost all looked only at whether or not critical appraisal is done, either yes or no, and how many reviewers do it. And that's about all the information that's considered. There's not been any detailed investigation of how critical appraisal is done. And you know, these sort of exercises have found that some rapid reviews do critical appraisal and some don't. But we don't really know, we can't say more than that without doing a detailed investigation. And I haven't done that because I haven't had time. And I don't think the CEDA database contains many, if any, rapid reviews, but it would be interesting to have a look. So I thought the next logical thing to do would just be to have a very quick look at whether the guidance that we've got on conducting rapid reviews matches these FEAT principles, these core principles of critical appraisal. And just as an example, I had a look at the DEFRA and NERC guidance on how to do quick scoping reviews and rapid evidence assessments. So this is not you know, homing in on this particular guidance, it's just a random off-the-shelf example of a set of guidance on how to do a rapid evidence assessment. And some key points come out. So this is an excerpt from the guidance, and the first thing we notice is they talk about relevancy and robustness, and they don't define either, but elsewhere in the document it's implied that robustness is equivalent to quality. So the one vague term is actually equivalent to another vague term. That's not greatly helpful on the transparency front. It's not clear what is meant by relevancy. I suspect it might be something to do with external validity, I'm not sure. And robustness might or might not have something to do with internal validity. This is really quite opaque in these guidelines. So the transparency aspect of FEAT is probably a fail, I would imagine, on that. And further on, we can look further into, the guidelines talk about combining relevancy and robustness. I mean, this is going back to conflating constructs, okay, and not only combining, but saying it's necessary to combine the scores given for relevancy and robustness. No, you shouldn't do this. You should keep these constructs separate. Okay, that's important. And then we're talking about scores. Well, I've already mentioned numeric scores are problematic. They really are very problematic. I mean, most quality constructs are not, continuous variables. They're not really applicable to mathematical operations. And trying to do that gives you a false impression that they have equal weight. But the guidance on how to do rapid evidence assessments here is recommending that we use scores. And not only that, but we use arbitrary scores, and then we start doing things with multiplications and things to them. So that doesn't meet any of the FEAT criteria. It's just an example. I don't know whether that's typical of rapid review guidance or not, but it's just an example. So just to sum up, because this has been a real quick whistle tour of the topic in 15 minutes or so, we feel that the FEAT principles could assist the planning and critiquing of critical appraisals for all types of evidence synthesis and could be useful for rapid reviews. Okay. Now, a key thing when you're doing a rapid review is to have a dialogue with the sponsor and other stakeholders as you progress the review, to make sure that when you do this streamlining, that it's proper streamlining, that you're transparent and you've chosen the right approach to do the rapid synthesis. I mean, part of that dialogue might be to say we don't actually need a critical appraisal at all. As long as that's transparent, that's fine. But if you do need a critical appraisal, then there's a logical structure here for deciding how to go about it. So for the focus part of the exercise, you need to determine and justify the assessment construct, if any. So are you going to focus on internal validity in a rapid review? And if you are you going to, and it's a logical focus if you're doing an effectiveness review, are you then going to include all of the domains of bias? Now, there might be a case to be made for not including all of them. If selection bias is a particular problem, maybe focus on that, because a rapid review does have to cut corners. Resources aren't unlimited. But this is a logical way of making that decision and documenting it transparently. And then you need to make sure that the assessment constructs are not conflated, as I've already discussed, and make sure that the critical appraisal informs the data synthesis. And having this structure allows you to think this through in the planning stage. And obviously use a meaningful output, not using an undefined quality scale that nobody can really pin down, and provide a rationale for the judgments you make. So, to cut a long story short, we think that these principles are potentially really helpful, and they're also quite useful in identifying critical appraisal tools that may or may not be fit for purpose. So there's some thinking there to go away and have a mull over. So just to conclude, because it's been a pretty rapid bolt through the world of critical appraisal, I think the key conclusions are we do need to understand the reasons why we've got such poor uptake of critical appraisal in systematic reviews. And once we understand that, then maybe we can improve the situation. I don't know whether organisations like CEE need to do more educational outreach or something like that, but there's a problem there that needs fixing. Complying with the FEAT principles could help make rapid reviews more reliable than some current systematic reviews, believe it or not, because obviously if a systematic review doesn't even have a critical appraisal step, and a rapid review has one that is very streamlined but very transparent, which of those is the better method? But there is a big risk, as I highlighted with the example guidelines, that we might end up repeating the same old mistakes, about conflating constructs and using summary scores and this general issue of what on earth does quality mean, and just recommending that we go forward with all these vague ideas isn't all that great. There might be an opportunity to sort of look at some of these guidelines because it's a new area and make some small tweaks to them and improve them considerably without major upheaval. So that's the thought. And I'd just like to say thanks very much to Paul Whaley, because I had some very, very valuable discussions with Paul about the utility of these FEAT principles. He's very supportive, and we think they're quite helpful. But I'd be very interested in your feedback and thoughts on that. So thanks very much for listening.
Great, thanks, Jeff. We do have a question, and just a reminder for folks listening that you can submit questions using the questions box. We'll handle what we can right after each talk, but then there'll also be a period at the end where we can circle back and address any that we haven't addressed already. So Jeff, someone had a question about why do you think the C reviews consistently fall lower than non-C reviews in addressing relevant bias domains?
I don't know is the answer. I don't know if any of us know the answer to that. When you go through the thought process about doing critical appraisal, a lot of people, I think in CE, we're very aware about the importance of systematic error and internal validity. So focusing on that is not really a problem. But I think we're less clear about where to go next. And often people think about just copying the risk of bias tool from health and copying some of those domains across, which might be a good idea. I don't know. Certainly, but a lot of the CE systematic reviews are missing those key domains. So attrition bias is a particular domain that's often missing. Missing data is not considered very often at all. So I don't know the answer to that really. And providing some clearer guidance on how to think this through would be helpful. And one of the things we were thinking is that maybe encouraging people to consider possibly using conceptual models or maybe directional acyclic graphs to look at the relationship between the variables in their review question, so that they can actually look for where confounding may occur and identify the key sources of systematic error in a systematic way, because it's quite challenging to come to a question cold and know where all the different confounding factors and other sources of systematic error may be. So there's some thoughts, but I don't know the answers.
Great, thanks, Jeff. We'll move now to our second speaker in the session. This is Nigel Taylor. Nigel is a postdoc at Tour du Valat, a wetland research institute in France. He's been working with a conservation evidence project for the past 4 years, synthesizing evidence for the effects of interventions to conserve wetland vegetation. And Nigel will be giving a talk titled Rapid, Large-Scale, and Accessible Evidence Synthesis, the Conservation Evidence Methodology. And Nigel, you're all set. Your slides are up.
Perfect. Thanks, Kate, for the introduction. Perfect French pronunciation. Thanks, everyone, for your interest in the seminar and attending today, wherever you are. So today I'm going to talk about conservation evidence methodology. And before I start, I just want to point out that I'm talking on behalf of a large group of collaborators here. Hundreds of people have worked on this project over the last 15 or 20 years. So many thanks to anyone who's been involved. But to start with, you're probably all well aware of the vast array of methodological choices that we have to make when we carry out an evidence synthesis. Everything from the breadth and depth of literature that we review to how we find the literature and how we synthesize and present our results at the end. And you're also probably also well aware that there's no single correct option here. There's no single correct combination of methods that is right for every single method, every single evidence synthesis problem. We have to consider things like the timescale, how much time we have available for synthesis, how urgent it is that we get an answer, the budget that we have available, the target audience, and the different outcomes that we're dealing with. Each of those will need a different kind of evidence synthesis method. And so today I want to talk about some of the methods used within the Conservation Evidence Project to synthesize evidence for the effects of conservation interventions in a format that's accessible to conservation practitioners. So I want to try and, while I'm doing this, is try and address some of the challenges that we face in synthesizing this kind of evidence and how our methods are tailored to those challenges. Also be honest about some of the trade-offs, some of the things that we sacrifice in the choice of our methods. So this diagram here is an overview of the whole conservation evidence process. Don't worry about the detail for now. It's all in this paper at the bottom of the screen if you want to follow it up later. It's just to highlight really that I'm going to go through 4 key stages within this process today, in the next 10 minutes or so. Talking about the scope of the project, how we find literature, how we summarize and synthesize the literature, and then the outputs that we produce at the end. So the Conservation Evidence Project spans the entire discipline of biodiversity conservation, or at least interventions within that discipline. So we're looking for evidence for the effects of any intervention to conserve any biodiversity anywhere in the world. That's a pretty big scope already. We break that down into various subject-focused work packages. So these are focused on perhaps a taxon like birds, a habitat like forests, or some other subject of interest to conservation practitioners. Within each subject, we try and identify every single intervention that could be done to conserve that target. And we have an advisory board for each subject-wide synthesis. And that's made up of academics and practitioners from around the world, and they help us to identify all those interventions. And then we try and map evidence that we find onto those different interventions. So the first key point here is my little key point symbols that will crop up throughout the talk. To emphasize that a fundamental unit of work is this subject-wide synthesis. So this will involve an author or a team of authors working for anywhere between 1 and 3 years. And you can see they're working across tens or often hundreds of interventions at once. This is quite a broad scope to work on, which necessitates some sacrifices in terms of the depth at which we can examine the literature. So how do we examine the literature? How do we find relevant studies? The key point here is that we carry out systematic manual screening of the literature. And we look at journals, both in English and non-English, languages other than English. And we look at sources of grey literature as well. So for example, we will look at the journal Restoration Ecology. We'll start at volume 1, issue 1, and go through titles and abstracts and pull out any studies that look relevant, look like they're testing a conservation intervention and quantifying the outcome. And then we'll put all of those studies into a discipline-wide literature repository. Any subject-wide synthesis can then take studies from that repository that are tagged with the subject, and that can form the basis of their further synthesis, full text screening and summarizing and so on. Each subject-wide synthesis will also look at subject-specific sources as well. So these sources, these journals, this grey literature might be relevant to a synthesis on wetland habitat conservation. So that subject-wide synthesis will pull out relevant journals, relevant articles from those journals, from those sources. But crucially, they will also pull out any studies relevant to any subject. So forest, birds, amphibians. All of those studies from these subject-focused sources will also be pulled out and put into this discipline-wide repository. In this way, each journal or source of evidence is only searched once for a particular date range by the Conservation Evidence Project. Once we search Restoration Ecology up to 2019, it's done. We pulled out all the relevant studies. The discipline-wide repository, this database, also builds up over time and accumulates studies. And each new subject-wide synthesis can save time when they're searching, because they can just pull out these potentially relevant studies from the discipline-wide repository. This cumulative process means that the cost per intervention of synthesis has dropped dramatically over time. After initial investment in this discipline-wide database, we can now synthesize evidence for each intervention very cheaply. The process is transparent in the sense that we can tell you exactly which journals have been searched between which dates for any subject-wide synthesis. It's updatable because if we search Restoration Ecology up to 2019, for example, it's easy just to add in 2020 just to search titles and abstracts for that year. And for me, one of the main advantages of this process is that it's exploratory, in the sense that we don't have to know exactly what we're looking for at the start of a synthesis process. We don't have to define all the terms used for interventions, all the synonyms, we can discover these as we go through, discover different ways of phrasing interventions, and often even entirely new interventions as we screen titles and abstracts. You may have spotted one issue with this process, that we will miss articles in journals that we haven't systematically screened, and to some extent we acknowledge that as a limitation. We do try and address it a bit with the advisory board, so they can feedback and help us identify the key journals that we need to be searching, key sources of evidence to search. And they can also identify key articles, key documents outside of the sources that we've systematically searched, and they can be incorporated into evidence. But yes, as I mentioned earlier, we're not going to capture everything through this method, just taking a sample of the literature. The next step is to summarize and synthesize relevant studies. So before I was talking about title and abstract screening. We then screen at full text, and anything relevant we can summarize in summary paragraphs. We then write key messages to summarize those narrative summary paragraphs. And then we carry out an expert assessment as well to generate an overall effectiveness category for each intervention. And I'll take you through each of these 3 steps one by one in the next couple of slides. So for each relevant study, under each intervention, we write these short, simple summary paragraphs. So about 150 to 200 words. We try and write in plain English, avoiding scientific jargon where possible. And the advisory board again feeds in here and helps us to write in an accessible manner and in an appropriate level of detail as well. Each summary paragraph has a set structure across all syntheses. So we talk a bit about the study design that gives some idea of the quality of the study. Talk about the dates when it was carried out, where it was carried out. A brief summary of the intervention that was carried out and the results that they found, and then a bit more information about the results, so reflecting statistical tests or not, and a bit of and some raw data to give you an idea of effect sizes too. And then we end up with a bit more information about the methods, how the intervention was done, and how the monitoring was carried out. The idea of presenting paragraphs in this way is that the readers can combine the paragraphs in different ways, almost carrying out a custom evidence synthesis. So, for example, they can weight studies according to relevance to their particular situation, as well as things like study design. At the moment, this custom synthesis process is left up to the reader. Maybe not all readers are doing this in a correct and appropriate way. We acknowledge that. So we have people, my colleagues in Cambridge, who are working on systems to formalise this process, working on tools and apps that can help to guide users to do this custom synthesis correctly. Once we have all the summary paragraphs for a synthesis, we write some key messages, and these are meant as an index or as a map to the summary paragraph. So there's key messages for each intervention. They tell you how many studies were carried out, where they were carried out, and then that's broken down by outcomes as well. How many studies, what were their design, where were they, and what did they find? We realise there is a temptation to use these key messages to vote count, which is not appropriate. We explicitly advise against that in our outputs, in our products. And you can also see that the key messages that are clearly linked to the summary paragraphs and appear alongside the paragraphs. So we hope it's obvious that you should be using both the key messages and the paragraphs together in order to make decisions and interpret the evidence. The final bit of synthesis that we do is to carry out an expert assessment, and this generates an overall effectiveness score for the intervention, generalised across all situations, all contexts. So this is a bit like your summary statistic for a meta-analysis. The overall effectiveness categories are these coloured areas on the graph down here. Generally, is the intervention beneficial, likely to be beneficial, ineffective or harmful, or do we not have enough evidence, enough good robust evidence to draw a conclusion? So the expert assessment panel is made up of academics and practitioners from around the world with expertise in a particular subject. They score each intervention on effectiveness, certainty, and harm to the target of the intervention. and that's based just on the evidence that we've summarized. And then through an iterative process, a Delphi-like process, we refine those scores, and experts can refine and update the scores until we reach a consensus and we get this overall effectiveness category. We find this is a useful way to combine the evidence and synthesize the evidence when studies are measuring often very different metrics, very different outcomes in very different contexts. So a lot of the interventions, the evidence isn't really amenable to meta-analysis, we find. At the moment, this process is a little bit of a black box. We give the experts clear instructions of what to do, but we don't know exactly how they're interpreting them. We acknowledge that as a limitation at the moment. So again, Alec and others in Cambridge are working on tools to formalise this process and make it more transparent. Finally, I just want to discuss the outputs of the conservation evidence synthesis. Each subject-wide synthesis is available as a synopsis. So these are PDFs freely available on the conservation evidence website. Some are also available to purchase as books if you prefer. The key messages and evidence assessment for each intervention are published in this What Works in Conservation book. It's kind of a summary of all the evidence that we've summarised. That's updated every year. But perhaps the most exciting output of the project is the website itself, conservationevidence.com. And here you can search for all the evidence that we summarise. You can refine by different locations, different habitats, different threat types. You can filter, you can sort in different ways. You can examine the evidence by intervention or by study. It's really a great way to kind of explore and play about with the evidence that we've summarised. And all of the outputs are completely free and open access. We're trying to break down these barriers involved with paywalls associated with scientific articles. So that's about all I've got time for. Just to repeat quickly some of the key features of the conservation evidence methodology that I've discussed. We carry out subject-wide evidence syntheses whilst building up this discipline-wide literature repository. Both of those build off each other. We identify literature through systematic manual searches and then summarise relevant studies with narrative summary paragraphs. We write key messages that provide an index or a map to those summary paragraphs, and then an expert assessment generates an overall effectiveness category for each intervention. The outputs are also accessible, both in terms of the language that we use, avoiding jargon, and also the fact that they're all freely available and open access. We realise that our methods complement other synthesis methods. We're not intending to replace systematic reviews and meta-analysis. We actually encourage those for interventions that are contentious or where there's a lot of evidence that's amenable to those other methods. And we're aware of shortcomings in our methods, trade-offs and limitations, and we're working on improvements where possible. And we're always happy to receive constructive feedback, criticism on what we're doing. And that's about it. Thank you for your attention.
Great, thanks, Nigel. I actually have a question. Could you talk a little bit about the resources involved in continuing to update and maintain the resource in terms of outside funding and in terms of staff time?
Yeah, I don't have all the figures to hand. Yeah, I don't know the figures, but it is a challenge to keep finding funding to update synopses. We do have a couple of fairly large funders that have funded quite large bits of work recently. It should be easier to find funding just to update. So updating the BAT synopsis has been updated regularly for the last 2 or 3 years, and that takes 3 or 4 months, I think. I don't know if that's full time, but it's a fairly quick process. So as we update things, we're searching for smaller chunks of funding, not millions or thousands and millions of dollars. It's small amounts of funding just to keep things updated.
Okay, thanks. Yeah, it seems sort of akin to monitoring issues. It doesn't take a lot of money, but it's hard to find people to fund it. Any other questions for Nigel? Please just submit them to the questions panel and we'll either address them now or at the end of the session. Okay, so the next speaker will be me. I'll introduce myself. Again, my name is Kate Schofield, and I'm an ecologist with the U.S. Environmental Protection Agency in Washington, D.C., in the Center for Public Health and Environmental Assessment. Sorry, I'm multitasking here. So hopefully everyone can see my slides. Please let me know in the chat panel if that is not the case. Today I'll be talking about using conceptual model diagrams as rapid evidence screening and evaluation tools. So sorry, my slides do not seem to want to advance. There we go. To begin, it's helpful to think about why we're looking at evidence in the first place. In our group, this is usually because we're doing some kind of assessment. Defined broadly, an assessment is just the act of making a judgment about something. At EPA, we deal with different kinds of assessments. For example, causal assessments to identify likely causes of some impairment that's already occurred, or ecological risk assessments to identify likely consequences of something yet to occur. Regardless of assessment type, we want these judgments to be accurate. That is, we want them to be supported by available, relevant evidence. We also tend to use a similar general structure. First, we formulate the problem, clearly spelling out what it is we're making a judgment about. Then we identify, evaluate, and finally integrate and synthesize the available evidence relevant to our problem. The problem formulation step involves two key components. The first is to clearly state the specific research question the assessment is addressing and to make sure that everyone involved agrees on that question. The second is to develop one or more conceptual model diagrams that visually lay out all the relationships that may need to be considered in the assessment. These diagrams serve multiple purposes throughout the assessment, but at this early stage, they help ensure that we're thinking about all the puzzle pieces we need to and that everyone's on the same page about what those puzzle pieces are. The evidence evaluated in any given assessment often comes from many sources and in many forms. But in pretty much every assessment, we consider literature-based evidence, what's already known about the question we're asking, published in some form. How we identify and evaluate this literature-based evidence can vary widely, particularly in terms of the resources, usually time and money, involved, and the information and defensibility of what we get from them. At the bottom end of the scale, with low resource investment, but also with little information, rigor, or defensibility provided, is the well-loved and oft-used method of cherry picking. I think sediment caused the impairment in my system. This study supports that idea. Great, I'll cite this one and I'm done. At the top end is a full systematic review. This obviously produces a lot of information in a very rigorous, defensible way, but is very resource intensive. We're interested in the methods in between these extremes. That is, how can we use or develop methods that are both robust and defensible, or at least as robust and defensible as they need to be, given the question involved and the level of rigor required, but also feasible, given that we're almost always conducting assessments under multiple resource limitations. Our colleagues in EPA's Office of Water were interested in puzzling out why phosphorus P levels in lakes showed an increasing trend from 2007 to 2012, particularly in lakes with low P levels. This presented us with a nice opportunity to explore that in-between space a bit. Our group began an assessment with several related components, one of which was a review of literature-based evidence. We kicked off problem formulation by pulling together a working group and developing a series of conceptual model diagrams to map out all the components we initially thought could be influencing the question. We ended up with 5 detailed diagrams, each focused on a different, relatively broad category of impacts. In this talk, I'll focus on the agriculture diagram, but all the diagrams are structured in the same way, with specific sources at the top, through more explanatory steps in the middle, down to increased total aquatic P in terms of loads or concentrations is the ultimate endpoint of interest at the bottom. Once developed, we thought that these diagrams could provide a useful structure for taking an initial look at what had already been published about these different relationships. So, with input from the working group, we identified 15 key sources and activities in the agriculture diagram, highlighted in blue here, that could be contributing P to lakes, things like animal feeding operations, tile drains, tillage practices, and other sources. And we were also interested in their effects on two key phosphorus pools, P in soils and total aquatic P, highlighted in green here. So for the agriculture diagram, this gave us the pairwise combinations shown here. Each of the source terms on the left leading to each of the phosphorus pool terms on the right for a total of 30 linkages. We use these 30 linkages to test a process for rapid, or at least relatively rapid, evidence screening and synthesis. So for each of these linkages, we conducted a standardized literature search by keyword for the specific source plus phosphorus pool terms, being sure to fully document our process as we went. We recorded the total number of returns for each search, then screened the 100 most relevant abstracts. After screening, we recorded the number and percent of papers that explicitly evaluated a relationship between the source and the phosphorus pool. We call these our included papers. We focused on papers quantifying these relationships because we were looking for measures of how these specific sources have been reported to affect these specific phosphorus pools. This information could then be used to identify knowledge gaps and hotspots across the diagram, to identify specific pathways for more in-depth review, for example, linkages with enough papers to warrant a more detailed look through a targeted systematic review, or to evaluate the size and consistency of responses with a little bit more work, which I'll come back to shortly. Once this searching and screening was completed, we had a series of heat maps like the one shown here for the aquatic phosphorus pool. The 15 source shapes are listed in the first column, along with 3 columns of information: total returns from each search, the percentage of those total returns that were screened, up to 100 abstracts for each search, and the percent of screened abstracts that were included or that reported a quantitative measure of the focal relationship. The number of included abstracts is listed in parens where 100% of returns were screened. And the columns are color-coded. Dark green indicates the initial search returned more than 500 papers, while light green indicates 100 or fewer returns. For the percent screened and included, dark yellow indicates more than 75% were screened or included, while light yellow indicates less than 10%. These columns provide us some useful big picture information. Total returns tell us the volume of literature that needs to be screened. If it's high, it suggests there's a lot of potentially relevant information about that individual linkage. The percentage screen gets at representativeness. How well does the screened subset of papers represent the total volume returned? And the percent included gets at relevance. How many of the screened papers actually quantify a relationship between the two variables, rather than, say, just mentioning both terms in the abstract? We can then look at how linkages vary in these parameters to get an overall idea of the body of evidence across all linkages. At this point, we circled back to the working group to discuss potential next steps. We've first simplified the conceptual models a bit, given what we learned from the initial searches. The revised diagram for agriculture is shown here. In our discussions, it became clear that our partners were especially interested in more detailed information about specific linkages. And those were centered on 2 sources, tile drains and conservation tillage, and how these sources affected 4 different phosphorus pools: P in soils, runoff, groundwater, and surface waters. After discussing logical connections between these source pool combinations, we identified 7 test linkages shown at the top here that we wanted to take a deeper dive into. Earlier I mentioned this rapid screening can tell us something about the magnitude and consistency of responses with a bit more work. And we decided to use these 7 linkages as test cases for this idea. We selected 24 included papers for each linkage and extracted a bunch of information from each paper: basic citation and study design information, information on the cause and effect, or the source and phosphorus pool variables, information about the relationship between those two variables, and other contextual information. We wanted to see if, by looking at the included papers, we could get a sense of the directionality, magnitude, and consistency of these relationships across the different papers. For example, do all papers show that tile drains result in increased P in surface waters? And if so, is that increase usually of a consistent magnitude, or does it vary? We're still working our way through the extracted information on these test linkages, but I'll mention a few preliminary points using the conservation tillage aquatic P linkage as an example. Of the screened papers, 42 were categorized as included. The 24 test papers we extracted information from quantified 114 distinct relationships between the two variables, between conservation tillage and aquatic P. Both tillage and aquatic P were defined and measured a bunch of different ways, which definitely complicates things. For conservation tillage, some papers looked at no-till practices, but others looked at a whole range of other forms of conservation tillage. Placement of these practices was sometimes targeted towards specific areas and sometimes more generally applied. Many papers looked at tillage combined with other best management practices rather than tillage alone. Study types also varied. Some measured responses in the field, but most involved model simulations. The same level of variability was seen with aquatic P in terms of the forms and measures evaluated. For response measures, most studies looked at mean differences between treatments. 90 of the 114 relationships assessed either an absolute or standardized mean difference. But these mean differences were highly variable in both direction and magnitude. Some studies showed conservation tillage increased P in aquatic systems, while others showed reductions. The amounts of these increases and decreases were also highly variable. Interestingly, this variability in responses doesn't seem to hold across the test linkages. For example, it initially looks like many of the tile drainage linkages are much more consistent in terms of direction and to some degree magnitude. But teasing these particulars out for all 7 test linkages is still a work in progress. The challenge with these methods is to make them defensible as an initial look at the evidence, but also at least relatively fast. We also want to make sure that we're giving our partners useful information. Quick and defensible isn't much good if the information we're providing isn't helpful to those who are asking us for it. We're currently testing a few different elements of the literature searching and screening processes for these test linkages to identify which components are giving us the most useful information, and by extension, which components we may be able to skip to save time. We're looking at whether the databases searched matter by examining search returns from the 3 databases shown at the left here. What's interesting so far, and a little scary, is that there's relatively little overlap in returns from the 3 databases. For example, for the conservation tillage to aquatic P linkage, each search provides a lot of unique returns. We're just beginning now to look at whether the unique returns in any of these databases tend to be more relevant in terms of including more papers that quantify relationships between the 2 variables. We're also looking at whether the number of most relevant papers screened matters, basically to figure out how much is enough when looking at search returns. The good news is that for each database, the percent of included papers tends to decrease as you move to less relevant sets of returns. The bad news is that it's not by much, with roughly 1/4 to 1/3 of later sets of returns still categorized as explicitly quantifying the relationship of interest. Ultimately, the determination of which methods are fast, defensible, and useful will need to be based on assessment-specific decisions that weigh what can be obtained from literature-based evidence, what's needed to sufficiently inform the assessment question, and what's feasible given resource limitations. We're hoping that the types of process comparisons we're examining here can help us more efficiently target these efforts in future assessment. Thank you. That's all I have for now, and I'm happy to answer any questions. Yes, so there's a question about, have you thought about using tools like Snorkel or other machine learning methods to target relevant literature? Yes, so we are looking at some of those tools, not Snorkel specifically, but other machine learning methods. And they do seem like they'll be helpful, particularly in terms of where they overlap with the other databases. We're thinking that looking at the overlap between some of those tools and what we're turning up through the databases may be helpful. And someone asked if we've considered other databases beyond those displayed. Yes, we have done that. These are the ones we used for this test case, but we have a list of about 12 that we're routinely using when we're attempting to be more systematic in the databases we cover. So we could look at those in addition to the 3 selected here. I'm happy to answer any additional questions at the end session. But for now, I'm going to turn it over to our next speaker, who is Sue Nichols. Sue is a senior researcher fellow in freshwater ecology at the Center for Applied Water Science, University of Canberra in Australia. Today, she'll be presenting on quantifying the ecological evidence for causal models using conceptual modeling, expert elicitation, and rapid evidence synthesis, a case study. And Sue, you are all set. Your slides are up.
Thank you. Can you see my screen?
Yes.
Yes?
Yes.
Pity I couldn't. Okay. As long as you can see my screen, I'll get started. Thank you, Kate. So just a bit of background then to this case study, and I'm just trying to find there we go. Okay, so just a bit of background to this case study that uses these 3 methods. Common carp are only one of 37 alien fish species in Australia, and they've been here a very long time and they're well established. But alien fish species are only one of the major threats to our native fish. There's habitat modification, flow regulation, and barriers to movement, just to name a few. But carp are public enemy number 1, rightly or wrongly. So along came the National Carp Control Plan, and that operates within the Fisheries Research and Development Corporation. And the plan was to develop safe and effective control measures for carp in Australian freshwater environments. And the focus was on the potential release of a carp virus. And there was a program of scientific and social and economic research undertaken to develop the knowledge governments needed to be able to make informed decisions on whether that virus release should go ahead. So the project that I'm going to talk about was only one of those projects, and it was about predicting the medium to long-term ecological effects of carp reductions, since they've been here for so long and entrenched in our ecosystems. So we weren't looking at the virus release per se. Other projects were doing that, looking at the short-term effects of large-scale carp kills. And if you want to know more about that program, there's a link there I can supply. So carp control then is based on the premise that reducing carp abundance will improve the health of aquatic ecosystems. So the aims of this project were to develop a conceptual framework and identify ecosystem attributes that were expected to change in response to carp control, and assess the confidence in the evidence that underpinned those predictions and identify knowledge gaps. So this hasn't been done before. There's no extensive evidence base in which to base those predictions. And even if we did have a crystal ball, we couldn't really necessarily use that to evaluate the confidence in those causal inferences. So the methods we then used were the expert elicitation, conceptual modelling, and we drew on the published literature in a rapid evidence literature synthesis. So I'll talk about the expert elicitation process first. It needed to be scientifically rigorous. That was important. So we used a particular published method called the Delphi approach, and enlisted social scientists also for their expertise. In one, developing the online survey that we used to elicit the views on ecological responses. We followed that up with 2 workshops where views the collated views were shared, and the confidence in the predictions was graded from high, being a 1 in 10 chance of being correct, to low, being a less than 1 chance in 10 of being correct. And the responses were aggregated with the range of responses then representing the overall uncertainty. So that was the expert elicitation. And we started off with conceptual models. We started off with a very simple generic model that showed how carp influence the ecosystem attributes, and by that we mean the water quality, the habitat, the fish, the water birds, etc. And moved to more conceptual, complex generic models on how those actual ecosystem attributes were expected to change in the response to carp. And we're able to put confidence on those causal pathways as well. And we did it for every, not everyone, but we did it for about 8 different ecosystem attributes, and I'm showing the one we did for the large native fish here. So that conceptual modelling then underpinned the predictions on how ecosystem attributes would respond in different ecosystem types as well. So the different types of lakes and rivers and wetlands, and the exploration of control scenarios that were based on the carp reduction, on how much population reductions could be achieved. So the experts were asked about scenarios where there was a do nothing scenario, so do nothing to reduce carp, through to 25% reduction in carp, a 70% reduction, through to a complete elimination of carp, although that was not necessarily considered a realistic expectation. In conjunction with that, we did the literature synthesis. So this was a rapid synthesis, very targeted to the causal inferences, the causal pathways. And we used the eco-evidence method for doing this. So it's an 8-step method in Norris et al. It's described there. The first part of that method is really about problem formulation. It's about the scoping. It's about defining the inclusion and exclusion criteria for the literature that would be reviewed. It's about putting that question into context. And the question that we were looking at was, will the ecosystem recover following the removal of a non-native, non-predatory freshwater fish? Not necessarily restricting that to the carp species we were dealing with, but a similar functioning fish in the ecosystems. So only then did we do the search and review and extract the evidence from the literature. We catalogued and weighted the evidence, and I'll talk about that in a minute. and then made a judgment on whether the hypotheses that we chose to use to answer that question was supported. The eco evidence tools can be found on the eWater Toolkit site. There's tools to help guide through this process, and also a database for storing that evidence that's extracted. So the sub-hypotheses then that we used to test that question were about those ecosystem attributes. Was there an increase in, so we looked at studies that did remove those pest fish species, and whether there was an increase in macroinvertebrate abundance, whether water quality improved, water plants, native fish and amphibian abundance as well. So the weighting then of the evidence. So studies that account better for environmental variability and error carried more weight in the analysis because they improve inferential power. So a particular evidence item was then weighted by its study design. So gradient designs and Bakke type designs get more weight, plus replication. That also increases inferential power. So more replication means more weight. So design weight and replication weight equals the evidence weight for each item that was used in the analysis. And here, so I'm showing that how we summed or combined that evidence. So the sum of the evidence supporting, so that's the response criteria, and the evidence refuting, that's the consistency criteria, was used. So for support, a hypothesis needed to have not only enough evidence, but it needed to be consistent. And here I'm showing the threshold rules that we used in the eco evidence and some possible outcomes. So it's for some studies greater than 20 points and consistency less than 20, so all of those refuting needed to be less than 20, then that hypothesis got support. If either of those thresholds were not met, then it would be insufficient evidence, and there was a possibility that maybe you could get support for an alternative hypothesis if there was more evidence for refuting than there was supporting. So the results then, so the experts predicted with 30 to 70%, well, sorry, predicted a 30 to 70% improvement over the current situation for water quality, water plants, macroinvertebrate communities and native fish. And they had a medium to high confidence in that result if the control measures could reduce carp biomass by greater than 70%. And the literature synthesis supported that prediction, except for the native fish. There was insufficient literature evidence to draw conclusions regarding the recovery of native fish, amphibians, water quality in terms of algae. So did we answer the question, will ecosystems recover following the removal of carp? Well, although uncertainty was high, the answer was possibly under favourable circumstances, and the literature evidence supported some elements of that. And by favourable, I mean where carp were the major driver of the degraded conditions in the first place, where greater than 70% reduction could be achieved of carp biomass with sustained control and other stressors also controlled. Native fish responses to carp reductions were likely to be highly variable. A degraded system also may not return to its original condition, and by that an example would be other alien fish species such as redfin may actually do better without carp and cause some sort of novel ecosystem to develop. complementary measures such as restocking native fish and restoring habitat would increase the likelihood of ecosystem recovery. Now that was very quick, but if you wanted the full report, it's available on that link there, and I can take some questions or email me questions. Thank you very much.
Thanks, Sue. If anyone has any questions for Sue, please just type them into the questions panel. So Sue, there's a question. First question is, were risks associated with viral evolution considered, such that a viral variant may infect native fish?
Yes, but not in my project. So that was one of the other projects. There was a lot of projects associated with this. It wasn't something we considered in this, because we weren't looking at the virus per se. We were looking at whether the reduction in carp by, and considering these are, in quite high biomass in many of our waterways, we're looking at what the effect was of removing such large numbers of carp that were well established in those ecosystems.
Okay, and it looks like you addressed the second question. I don't know if you want to say anything else about it, but the question is, how are the results of the different projects being integrated?
Yeah, still ongoing. So they haven't made a decision on that yet. Part of the process was, that final point I made there about complementary measures were very important. So just reducing carp alone might not be the silver bullet, so to speak, that there is, a need for other measures such as restoring habitat and restocking and all of that to be considered as well. So there's some targeted projects being undertaken to address some of the, I guess, limitations of the previous round of studies.
Great, thanks, Sue. We'll move on now to the final talk in this session. This is going to be given jointly by Angus Webb and Sylvia Lee. Angus is an associate professor in the Water, Environment and Agriculture program at the University of Melbourne, Australia. Sylvia is a biologist at the U.S. Environmental Protection Agency's Office of Research and Development in the Center for Public Health and Environmental Assessment. Angus and Sylvia's talk is titled Sampling the Literature, What's Gained and Lost by Taking a Non-Exhaustive Approach to Searching the Evidence. And you guys are all set, your slides are up.
Okay, hearing me okay, Kate?
Yes.
Okay, and Sylvia will be controlling the presentation, so I'm going to have to regularly say, can you press down, please, or something like that. Thanks for that introduction, Kate. So as mentioned, this is going to be a team effort between myself and Sylvia. I'd also like to thank our other co-authors on this work and acknowledge the contribution of Kai Yang and Rui Peng, who were Masters of Engineering students who did a small research project with me in 2020 on a similar topic, and thus whose work shaped some of our thinking in this area. So we are talking about whether we can sample the literature in evidence assessment. Down, please. So we're all very well aware that systematic review in particular can support evidence-based practice in environmental research and management. And we're also aware that current standard approaches are very resource intensive. And feedback that I've had, definitely I've had, and I think others as well, from potential users in government and private industry and so forth, has told us that this resource intensiveness means that those bodies are unlikely to embrace systematic review, in Australia anyway, as a form of evidence synthesis anytime soon. Now, at least one other talk in this series has shown us a different version of Hokusai's Great Wave off Kanagawa, but what they've had in common is that we are drowning in literature. Papers in all disciplines are being produced at an ever-increasing rate, but at the same time, our current guidelines in systematic review require us to do our very best to conduct a full census of the literature. So a census is where we consider all possible relevant papers and reports while undertaking our synthesis. Down, please. So we want to ask the question, what if we use samples of the literature instead of the full census? And this question is based partly in practicality, but it's also based a little bit in logic, because after all, nearly all science, and I would wager pretty much every single one of the studies that we include in systematic reviews, reach their conclusions based on samples of populations rather than entire populations. And so we need to ask the question, if it's good enough for the rest of science, why shouldn't it be good enough for systematic review? So to do that, we're using evidence from an in-progress CEE review to test two questions. How good are samples of different sizes at estimating the population level effect size, which we're calling the true effect size here, although the word true is debatable. And also, how good are they at detecting significant non-zero effect sizes? At the same time, we've been tracking information on the time it takes to process studies for the systematic review, and Sylvia's portion of the presentation will report on the types of savings that might be possible if we limited time spent on extracting evidence from individual studies. Down, please, Sylvia. So the test case that we're using is a CEE review that the EPA are completing at the moment, building on what Kate said before about sources of phosphorus. They're looking at evidence for the environmental impacts in inland waters resulting from nitrogen and phosphorus enrichment. So there are several different endpoints in the study, and there's also the assessment of modifying factors. But for the work presented here today, we're just looking at increases in chlorophyll A. Down, please. Here's a little bit of information on the chlorophyll dataset, and for the results I'm presenting, we're going to look at relationships between benthic, that's chlorophyll on the stream or lake bottom, and cestonic, which is up in the water column, chlorophyll, and the concentrations of total nitrogen and total phosphorus. So that gives us 4 potential cause-effect hypotheses, and you can see that different numbers of studies were found that address each of these. Down, please. So we've done this using a Monte Carlo approach. For each of several different sample sizes, we've generated 1,000 samples for each of the 4 stressor-response relationships. And then we've tested the 2 hypotheses that I mentioned earlier. Down, please, Sylvia. And this is an example of what the results look like. On the left of your screen are box plots of individual effect size estimates created from 3 different sample sizes. So each of those box plots contains 1,000 data points. And on the right, the histograms show those individual estimates. There are 2 things I'd like to draw your attention to on this slide. First is that there's quite a wide range of effect size estimates when we use 10 samples out of the population to come up with that estimate out of 37. And as that sample size becomes progressively larger, the box plot becomes narrower, as one might expect, and so does the histogram. So 2 things to remember. It's actually pretty rare for an estimate to be very close to the population level mean, which is 0.395 there in the blue line. but also very few of these estimates are close to zero, where we might see non-significant results in a statistical hypothesis test of whether or not there's a positive effect size. Down please, Sylvia. So summarising across those 4 cause-effect hypotheses, the pattern is repeated for effect sizes. Now, these y-axes are all comparable. I should have mentioned it a moment ago. What they actually are Z-transformed correlation coefficients. And you can see that the weakest overall effect exists for the relationship between total nitrogen and systonic chlorophyll in the bottom left corner. But all sample sizes of 10, all analyses with a sample size of 10 return quite a wide range of effect size estimates. Hit down, please, Sylvia. So our take home from this is that it's really quite difficult to get an overall effect size estimate that is very similar to that from our full population of studies, unless we use a large subsample of the literature. And down, please. In contrast, though, if we're looking at the ability of these samples to detect a significant non-zero effect size, the results are a lot more rosy. Because most of these effect size estimates are above zero, and in many cases well above zero, the proportion of subsample estimates that show a significant positive effect is high. And this is literally statistical power. There is a true, or at least a population level, significant non-zero effect for each of these 4 hypotheses. And we've got a good chance of detecting that when using samples. The only one we'd really be worried about the power here is the total nitrogen systonic chlorophyll relationship in the bottom left corner that I spoke about earlier. And that's come about because a couple of the 10 sample estimates are below zero and a few more are near zero. And so we've only got a 46% chance of detecting the effect as significant if we take 10 samples at random from that population. Down, Sylvia. So overall, however, we conclude that the statistical power to detect true non-zero effect sizes is generally high, even with quite small sample sizes. So at this point, I'm going to stop speaking and hand over to Sylvia to talk about the rest of the work.
Thank you, Angus. So this part of the talk factors in the time spent on reviewing each citation. We were able to do this analysis because the review team recorded how long it took to review the full text of each citation during the full census. Reviewing a single citation sometimes took less than 5 minutes, or other times up to nearly 14 hours. There are many reasons for this, including citation type, such as a journal article focused on an experiment, or a report on the condition of streams sampled across an entire state. There are also different numbers of effect sizes per citation, as well as the amount of contextual information associated with the studies. So this is a forest plot of the full census results with the 4 different stressor response relationships shown on the left. These are the same ones as discussed earlier by Angus. The N values in the next column are the number of articles, and on the right are the mean effect sizes, or the true effect sizes, with their 95% confidence intervals. And we subsampled each of these 4 relationships by citations that took up to 1, 2, or 3 hours to compare the mean effect sizes against the full census results. And this is an example of one of the relationships, total nitrogen and systonic chlorophyll A. The 4 rows here are the different review times, and the yellow highlighted row labeled all contains the same data as the full census results, also highlighted in yellow here. And the most important part to notice in these forest plots is the overlap in confidence intervals. For example, 0.25 Pearson correlation falls within all of these intervals for the smaller subsample groups. And nearly all subsamples had 95 confidence intervals containing the full census effect size. There was really just one exception for total nitrogen and benthic chlorophyll A, where the full census effect size 0.35 did not fall into one of the intervals, but at least there was some overlap between these confidence intervals. So these are the same plots, but I replaced the number of articles with the total number of minutes it took to review the citations. And I wanted to know what fraction of the total time was spent reviewing citations that took up to 1 hour per citation or less, compared to the time it took to conduct the full census and still get pretty close to the true effect size. For example, it took 38 minutes to review the citations within the 1 hour category, while the full census took 1,086 minutes, which is about 18 hours. And 38 minutes is 3.5% of 18 hours. So taking the average of these percentages turned out to be just under 10%, showing that we may be able to spend about 10% of the time reviewing citations in a full census and still approximate the true effect size. These time savings could then translate into money savings of about $25,000 to $50,000. This is just a rough estimate I based on 2 hourly rates, which I thought were comparable to a junior scientist and a more senior scientist conducting the reviews, and 545 hours to conduct the full census. This is a back of the envelope estimate, which I think is fairly conservative, but there are some important caveats. The reported times do not include breaks, which were really important actually for maintaining our sanity while reviewing many papers. They also do not include the time we spent conducting data quality checks, such as reconciling differences between reviewers or standardizing units. I also note that the extractions that took less than 1 hour were potentially not useful for other goals of the systematic review, or the articles were poor quality, so we didn't spend much time on them. In terms of our other goals, our stakeholders were interested in more than one endpoint. So if a paper on chlorophyll also had information about diatoms or macroinvertebrates, we spent additional time on that paper. We were also not just interested in effect sizes, but our second question of the systematic review was how contextual variables like watershed area, light, and temperature may influence the relationship between nutrient concentrations and the 3 endpoints. If the authors were very thorough in their reporting, which is actually a good thing for our systematic review, that increased the time to complete a review beyond the time needed to just capture the effect sizes. It's also important to consider that stakeholders may require a full census, even if it is resource intensive to obtain, if the question is very litigious and bias in the evidence base may be a big concern for them. Also, we would need to know if the stakeholders are looking for an exact value or if they really just need a general idea of what the evidence shows. For example, a significantly non-zero relationship between nutrients and chlorophyll A concentrations. So in summary, precise estimates of the true effect size require relatively large samples of the full body of literature, but statistical power to detect a true non-zero effect size is high even for quite small sample sizes. The suitability of subsampling therefore depends on the question, and keep in mind that most scientific endeavors make inferences using samples because we cannot measure entire populations. Evidence synthesis methods that can reliably employ samples of the literature would be a major advancement and potentially save a lot of time and money. Together with other initiatives to improve efficiency, rapid assessments have the potential to improve uptake of evidence syntheses in environmental science and management and drive the effectiveness revolution that we know is possible. For our future work, we are exploring different ways to subsample full census data sets and test rapid evidence reviews. I listed some examples here, but welcome any ideas or thoughts you may have about this work. And we can discuss them now, or feel free to follow up with us by email. Thanks for your attention. Thanks to the review team for developing this full census data set, and thanks to the organizers of the Evidence Summit.
Great, thanks, Sylvia. Thanks, Angus. If you have questions for Sylvia and Angus or for any of the other speakers, please feel free to enter them into the questions panel, although we may have lost Jeff and Nigel to sleep at this point. But if you have questions, I'm sure the speakers would also be willing to answer them via email. And Sylvia, do you mind advancing one slide? Thanks. Just a plug I'd like to make is that if you're interested in further exploration of some of the topics presented in this session, we're currently planning a more in-depth webinar series on rapid evidence assessment methods and applications to be held in spring and fall through fall of 2021. Some of the topics that we're interested in including our existing methods and guidance for rapid evidence assessment, many of which we heard about in the talks today, what's gained and lost through these methods, how they're currently being applied in environmental management, and improving the match between methods and needs. So if you're interested in this, please email us if you'd like to receive information about the webinar series, or if you have other suggestions for a possible webinar topic. Oh, and Jeff is still awake. That's good to know. Any questions for any of the speakers at this point? No? Okay. In that case, I think we can wrap up the session. Jess, I believe you had some closing words.
Yes, thank you, Kate, and thank you to all of our presenters today. I'm just going to put up, hold on. There we go. So yeah, just want to thank everybody for joining us today. I know it was a little bit late in European time zones, but just want to welcome you to join us for the, that should say, April webinar, Advances in Agricultural Evidence, which will be April 13th. Registration is now open. And I'm just seeing, looks like there's another question came in, but it wasn't a question, just said very stimulating cases and ideas, and thank you to the presenters. So I will echo that as well and wrap things up. So thank you, everybody, and enjoy the rest of your day.